Numbers are used quite often in programming to keep scoring games, represent data in visualizations, store information in web applications, and so on. Python treats numbers in several different ways, depending on how they are being used. So let's first look at how Python manages integers, because they are simplest to work with. So you can add, subtract, multiply, and divide integers in Python. Let's do this following example. My value here, 2 plus 10 here, and let's print this value, my value. And here you can see here 2 plus 10 is equal to 12, or let's actually 9 subtract here 99 here, and as you can see here, my negative 9 negative 90, and let's multiply it. For example, multiply 5 by 10. Oops. Multiply 5 by 10, and here we have 50. And let's actually divide 5 by 10 and 0.5. So in a terminal session, you can also Python simply returns the result of the operation. And here Python uses two multiplication symbols to represent exponents like this. For example, 5 exponent 10 is equals to this here. For example, 3 exponent 3 equals 27, and 10 exponent 6 equals 1 here, 1 2 3 1 million here. So Python supports the order of operations too, so you can use multiple operations in one expressions. You can also use parentheses to modify the order of operations, so Python can evaluate your expression in the order you specify. For example, this. So my value here, 2 plus 3 and multiply by 4 or 5. And here you can see we first 5 multiplied by 5 here. So the spacing in these examples has no effect how Python evaluates the expression. It simply helps you more quickly spot the operations that have priority when you are reading through the code. And we also have floats in Python. So Python calls any number with a decimal point. Python calls any number with a decimal point is a float. For example, this 478 is float. So this terminology is used in the let me actually firstly fix this here, because our marker menu should be here somewhere. Yes. So the term is used in most programming languages, and it refers to the fact that a decimal point can appear at any position in a number. So every programming language must be carefully designed to properly manage decimal numbers, so numbers behave appropriately, no matter where the decimal point appears. For most part, you can use floats without worrying about how they behave. Simply enter the numbers you want to use, and Python will most likely do what you expect. For example, 0.2 plus 0.9, and here 1.1, and here, for example, 2 multiplication 0.2, and here, oops, sorry, yes, 0.4, and here we have the run it again, yes, 0.4, and here we have 2 multiplication by, for example, 99 here with some this, and here you can see we multiply this number to 2. So this happens in all languages, and let's actually, there's some bug here. Not bug, but you should see it. So here we have 3 multiplied by 0.1, and this here. So and this is a little concern, right? This happens in all languages here, in C++, in Java, and so on. So Python tries to find a way to represent the result as precisely as possible, which is sometimes difficult given how computers have to represent numbers internally. Just ignore the extra decimal places for now, and you will learn ways to deal with this extra spaces here. Just here, ignore this here for now. So when you divide any number, when you divide any two numbers, even if they are integers, that result in a whole number, and you will always get a float in mathematically, right? So let's do this. For example, 4 here, 2, and we got 2.0 here. So if you mix any integer and float in any other operations, you will get a float as well. Like, for example, 1 plus 2.0, and we got 3.0. Let's actually use 2 multiplied by 9.0. We got 18.0. And if we this same applies for the multiplication here, exponential exponents. So 3 exponent 2.0, we are seeing here 9.0. So Python defaults to a float in any operation that uses a float. So even if the output is a whole number. When you are writing long numbers, you can group digits using underscores to make large numbers more readable. For example, this. The students. And here we will use this students variable as a count of students. For example, let's make it for 50 million, right? So when you print a number, students, print students here. So when you print a number that was defined using underscores, Python only prints the digits. So Python ignores the underscores when storing these kinds of values, even if they don't group the digits in trees. And the value here, let's actually, the value here will be still affected. So for Python, the 1000 like underscore after 1 is the same as underscore after 10. So this feature works for both integer and floats. And we also have multiple assignment here feature in Python. So you can assign values to more than one variable using just a single line of code. So this helps you shorten your programs and make them easier to read. And you will use this technique most often when initializing a set of numbers. For example, here's how you can initialize the variables a, b, c to 0 here. A, b, c, and here 0, 0, 0. 0, 0, 0. So you need to separate the variable names with commas here and do the same with the values. So, and Python will assign each value to its respective variable. As long as the number of value matches the number of variables, Python will match them up correctly. So let's print this here. Print a here, a equals to a, and print b equals b. Let's print the b. Print here and c. Now we will here, and as you can see here, a equals to 0, b equals to 0, and c equals to 0. If we delete this, we will get an here error because non-iterable ink project. So if you do like this, for example, a equals to 0, b equals to 98, c equals to, for example, 55. And here, as you can see here, we assign them accordingly. And we also have constants in Python. So a constant is a variable whose value stays same through the life of a program. So Python doesn't have built-in constant types, but Python programmers use all capital letters to indicate a variable should be treated as a constant and never be changed. So for example, one of the constants might be, for example, maximum number of, for example, maximum value here, or maximum customers, for example, and in this case, let's make maximum customers 500. So when you want to treat a variable as a constant in your code, write the name of variable in all capital letters. And we also have comments in Python. So comments are extremely useful feature in most programming languages. Everything you have written in your programs so far in Python code. So as your programs become longer and more complicated, you should add notes with your programs that describe your overall approach to the problem when you're solving. So a comment allows you to write notes in your spoken language within your programs. So how do you write comments? In Python, the hash mark, this hash mark, oops, sorry, fix that. So in Python, this hash mark indicates a comment. Anything following this hash mark here in your code ignored by the Python interpreter here. So for example, let's say this, right? Oops, here. Hello everyone. This is a comment and I'm explaining something about my code. So here, after that, we will print, example print, hello my students here, students. Now we will print this, and as you can see here, Python ignores the 5th line here and executes the 2nd line. What kinds of comments you should write? So the main reason to write comments is to explain what your code is supposed to do and what you are making it work. So when you are in the middle of working on a project, you understand how all of the pieces fit together. But when you return to a project after some time away, you will likely have forgotten some of the details. So you can always study your code for a while and figure out how segments are supposed to work, but writing a good comments can save you time by summarizing your overall approach clearly. So if you want to become a professional programmer or collaborate with other programmers, you should write meaningful comments. Today, most software is written collaboratively, whether by a group of employees at one company or a group of people working together on an open source project. Skilled programmers expect to see comments in code, so it's best to start adding descriptive comments to your programs now. So writing clear, concise comments in your code is one of the most beneficial habits you can form as a new programmer. So when you're deciding whether to write a comment, ask yourself if you had to consider several approaches before coming up with a reasonable way to make something work. So if so, write comment about your solution. It's much easier to delete extra comments rather than go to back and write comments for sparsely commented program. For now, I will use comments in examples through this course to help explain sections and codes of this course here.